give it maybe 30 more seconds here, and then we'll kick this party off. Yeah, for folks online, again, thanks to the Linux Foundation. So we're also going to be posting this to the Linux Foundation Data and Analytics YouTube site. Just to give everybody a heads up. I'll start my let's get this party started. So hello everyone, welcome to Cleveland Big Data. It is July 12th, 2021, and welcome to the virtual style meetup. So we've got a great lineup tonight. We've got a short community announcement from Teals. We've got Holden Karau from Netflix doing a talk on migrating Yarn to Kubernetes. And Holden, I hope you don't mind, but I added the exclamation point at the end of your talk. An exciting opportunity to make old mistakes new again.
I love it.
Steve Howard, Apache Kafka for streaming machine learning initiatives, and Andre DeWaal, Open DS for All, an open education project to accelerate the development of data science curricula worldwide. A fantastic lineup tonight. Very excited. So the format's going to be the same. It's a 20-minute. It's timed. It's the speaker's choice on where they want to take questions. If they want to save time at the end, if they want to take them during, I can read off questions. The speaker, just tell me what you want, or no questions. That's okay too. So just tell me what you want before each slot. So a few key announcements here. So the member approval process, and again, we had a lot of drive-by spam last year. So I am doing the member approvals. I approve just about everybody. Sometimes I will ask a few questions just to make sure you're a real person, especially if you're a member of like 100 meetup groups. Sometimes I'm just going to check and make sure you're not a bot. So please don't take it personal. So that's still in effect. And again, a friend of the show is a moniker that you can use on your resume, business card, or to impress your relatives. You can earn that title when you do a talk at the meetup. It's yours for life. It's like a life peerage, but you cannot gift it to your children or spouse. So that's the downside. But it is yours for life. The other thing is for the September meetup, I am planning a relative mega meetup. So obviously, for folks that have been around, they know that the September time frame has been where we've had mega meetups and done something really big for hundreds of people. I'm going to go for a relative mega meetup, which means we're going to have a non-zero integer number of people, hopefully meeting in person in a hybrid setup, maybe even up to 25 somewhere in the Cleveland area. So it'll be a combo, hopefully in person for anyone that feels comfortable with that, as well as also a Zoom meetup. So it'll be more like a regular meetup, except the fact that we're also going to do it in person, and we can also bring in some pizza as well. So look for announcements on that. So it's relative mega based on our current baseline of no in person. So and also, as always, thanks to Chris Barrett and also to Linux Foundation, who lets us use their Zoom and also post things on the Zoom channel. Also, real quick, so shout outs, recruiting shout outs for folks that are looking for things. I had asked for that earlier in the day. I didn't get any, but I'm just asking now. So if anybody has any recruiting shout outs, please put it in the chat and I'll read them out. Got it. Jeff Wallace from OCLC. I can't read that URL, but so please check out the Workday jobs. Check the chat out for folks that are online. OCLC is actually a longtime friend of the show. I remember having an OCLC speaker, back in, I think, 2014. So again, good to see you. Thank you for coming. Anybody else? Progressive, one from Chris. Check out progressive.com/careers. Openings for data engineers, developers, data scientists, and analysts. And let's use the popcorn effect here. Any more? Confluent, Derek Kane from Confluent. Check out positions there on LinkedIn for a solutions architect remote. And looks like that's it. So thanks a lot, folks. Again, check the chat, look for the URLs. And with that, Amanda with Teals, if you got 2 minutes, do your thing.
All right, thank you.
Oops, sorry. Roger French at Case. That's 2 postdoctoral scholar positions focused on big data and analytics on energy systems. Check out sdle.case.edu. That's sdle.case.edu. Thank you very much. Sorry about that, Amanda.
No, that's all good. All right. And then.
You want me to stop sharing?
Yeah. I just have
got it.
one slide to pull up here. There we go. Okay. And I'll make this look better. Here we go. I don't want to start from the beginning. Hold on. Now I've lost it. All right, so I will quickly, while I try to get my slide back here. So my name is Amanda O'Mara. I'm from the Microsoft Teals philanthropic program. It is my goal for this year to not trip up saying philanthropic. But basically, we are in the Cleveland area. I'm actually new to the team, not new to the area. I'm from Akron. I grew up in Sandusky. I've worked up in Cleveland a handful of times. Here we go. Trying to get this to come up. I cannot get this to. All right, we will just look at it the ugly way. Anywho, I come from classroom teaching. I taught out in Portage County, and Google was my first tech tool, or not my first, but like my primary tech tool. So me and Microsoft products, we're still learning each other. So I apologize for the format. But anyway, we are working to put computer science programs into local high schools in the Cleveland area. I'm always surprised by how low the percentage of CS programs are. Specifically Ohio, I think it was in 2012 when they did the survey, or 2014, that only 47% of our high schools have CS programs. That number's moved up a little bit, but not by much. So part of what Microsoft is doing is we offer training to the schools. We offer them the curriculum and training for their teachers, but we also partner with local industry volunteers. So people such as yourselves, anyone that has a passion for computer science and teaching. We have a fair amount of people that are coming from boot camps and are CS students, all the way up to industry veterans that have been in it for a long time. But the idea is that you're there to help support a teacher who's learning how to teach computer science, who has never taught it before, more than likely. I have home ec and art teachers and music teachers that are teaching this. And you're bringing in that industry knowledge to the classroom. So you're sharing with the students, what you've learned in your experience, but you're also helping the teacher as well. And then the idea is eventually, after a few years of that volunteer support, the teacher's confident enough that they don't need to have a volunteer supporting them. Although we do have a fair amount of schools that keep their volunteers on. I know I have a couple in the area that they'll always have that volunteer, which is great. The commitment for the 21-22 school year, we ask that you come in 2 days a week. Classes are in the first period of the day, so they don't conflict with your work schedule. So usually between 8 and 9 a.m. as most of my schools is when their first period is. And then we do have a very large amount of remote volunteers. Microsoft, we know that software developers and everyone working in this industry is becoming more remote. So, and especially after the past year, our schools are now set up for this. So, don't let that be a barrier. If you're not in Cleveland proper, that's a-okay. I have volunteers from all over the country coming into Cleveland virtually to volunteer. So if this is something you're interested in and you'd like to learn more about, I am still looking for a handful of volunteers for this school year. All of my link fun stuff is up there, and I'll pop it in the chat here in a second. Our I will say our volunteer application is not currently live because I'm kind of outside of the recruiting season. But being that I'm new to the team, so to speak, I'm a little behind because of coming in so late. So we still are taking volunteers. I just have to send you that link. So if you go looking for it, that's why you can't get to it. But you can email me directly. It's just amanda@tealsk12.org. Or if you do that contact form on the Microsoft site, it funnels it right to me that way as well.
Cool.
So
Thank you very much, Amanda. And first up is Holden, and take it away.
Rock, and hopefully y'all can hear me and see my slides.
Yep, they look good.
Yay, party. Okay. So yeah, I'm going to talk about migrating from Yarn to Kubernetes, specifically around big data. And this is an exciting opportunity for us to make all of our old mistakes new again. And the images here is some Yarn and me renting a Vespa instead of going to KubeCon, because it turned out I could rent some Vespas at very affordable prices during the day of the KubeCon conference. It's okay. I went to the other day, I promise you. So it's some facts. Also, I do love Vespas though. So I'm Holden. My pronouns are she, her. I'm on the Spark PMC. I contribute to a bunch of other projects. If you're interested, I do a lot of open source live streaming. It's up on YouTube. And you can also check out my GitHub. The important thing is I don't necessarily speak for my employer. I appreciate that they let me do a bunch of random things, including streaming, open source stuff. So please don't hold it against them if I say slightly incorrect things. They're entirely my own fault. In addition to who I am professionally, I'm trans, queer, Canadian, in America on a green card now as of last year, and a part of the broader leather community. And this isn't directly related to the work that I do, right? There's no secret Canadian JVM settings we've been hiding from you, or any secret Canadian Kubernetes settings, although there is a poutine.yaml file, which if you ask Pop for, he'll be willing to share with you. This is more, I think it's important for us to talk about where we're from, especially for those of us who are building data tools, and to look around the room and, virtual rooms in the past few years, of course, and see if everyone maybe has the same background as us. And if that's not the case, that's great. And if maybe everyone does have the same background as us, maybe, we should try and see if we can get some different people in the room and have some different perspectives present. So that being said, what is this all about? So this is about Yarn. If you're not super familiar with Yarn, that's okay. You can just think of it as a cluster manager. It comes out of the Hadoop ecosystem. Kubernetes is also another cluster manager. We're going to talk about how they're similar, how they're different, how we can make Kubernetes work with big data, and specifically a lot of the mistakes that we're sort of relearning again on Kubernetes. And this is my dog. He is adorable. He is the reason that I get up in the morning instead of just going back to sleep. I love him more than open source software. So yeah, what is Yarn? Yet another resource negotiator. It's developed to support big data workloads. And this is important that Yarn really never took off outside of that space. And this is, slightly problematic in terms of if you are trying to be a cluster manager, if you're only really used for one type of work, it turns out that most companies do multiple kinds of work, not just analytics workloads. Very inconvenient for those of us working in the analytics space. But it turns out often you have to have these things called customers and users, and those people have different requirements than batch jobs. Yarn has some level of isolation between multiple users and jobs, but not necessarily quite as much as one might hope, especially for people who use Python. This has been really painful because setting up isolated Python environments is really challenging, and Python dependency management with Yarn is quite painful. It is also locality aware. This is really useful when it comes to data. because it turns out that transferring data is kind of expensive. And it supports different applications, right? Like my experience with Yarn is mostly from a Spark standpoint, but it's important to note that it is more than just Spark. You can run Hive, MapReduce, Impala, all kinds of things on top of it. It also supports nested queues. And this doesn't necessarily sound super cool unless you're coming from maybe imagine trying to get your children to share their toys with no rules, and then replace your children with employees who don't talk to each other in different sides of the country, who both believe that their work is the most important work that there could possibly be. And it turns out that at the end of the day, sometimes someone's most important work is not the most important work. And we need some ways of deciding that. And having nested queues for sharing of resources and priorities is a way of doing this. All kinds of fun. It's written in Java, which to me is kind of nice because I can read Java code pretty well. To some people, writing system software in Java isn't super fun, and I can't say I blame them. I get it. So Kubernetes doesn't have a cool acronym like yet another resource manager, so that's different. And instead of coming out of sort of the big data ecosystem, it very much came out of more of an interactive or arbitrary or application sort of background. If you're familiar with Google Borg, it's sort of more inspired by that. It's similar to Yarn, it's a way of requesting resources. It has a lot more isolation between users and jobs. It does have some understanding of locality, although it doesn't pair this with data in the same way. It supports all kinds of different applications. And I mean, it supports so many that I forgot to fill it out, but also it's written in Go, and this, to the people that write Go, will probably be sad. It looks a lot like Java code because of the way how they named all of their things. And to the Java developers, the fact that it's written in Go will be sad. So don't worry, we can compromise and make everyone sad. Yay. Oh wait, you can't see me. I just did finger guns. Don't worry. So how are they the same? So they schedule things called containers. However, they have a very different understanding of what a container is, right? And so this is great in that they both say they do the same thing, but mean something completely different by that. They're both open source, and like many open source products, they've evolved organically, which is a polite way of saying a whole bunch of people who never really agreed with each other wrote a whole bunch of code and merged it together. And they both run on computers, which is pretty cool. Although alternatively, computers are not cool. And so we can think of it as being kind of similar in the way that the patch for my Scooter Club, the Sparkling Pink Pandas, is similar to all of these other patches. They are indeed both patches. However, there are some important differences. While they are both an implementation of the patch, they are very, very different. But of course, whenever we've got two standards for something, the natural inclination is to try and make them the same, right? And normally what happens is someone comes along and makes a third standard. And I'm excited to tell you that that's what's happened here today. And actually, in this case, it's not just a third, it's a third and a fourth. And so what happened is someone decided, you know what, these two things are really, really similar. I'm just going to build a project that's going to make both of them look the same to each other. And so they built something called Unicorn. And it's actually a really cool project. However, it has some downsides. And sort of one of these things are when we try and create a system that is like taking two different APIs and exposing those same APIs back out to everyone and just translating the calls in between, what happens is you start to get into these situations where, yeah, they both can schedule containers, but they both have a very different idea of what a container is. And so you either end up spending a lot of time implementing the other one's idea of what a container is, or implementing the other one's idea of what a queue is. Or if you want to really do it super well, you're going to end up spending a bunch of time implementing all of these features for both of them. And so Unicorn does some of that, but not all of that. And the only way you'll find out is by calling the APIs and seeing what fails. If that doesn't sound fun to you, let's keep going. If that does sound fun to you, go ahead, install Unicorn today. And I want to be clear, like Unicorn is pretty awesome. I think it does meet a very valid use case, just like it doesn't magically fix everything. Like most things that claim to magically fix everything, he's not quite there. Okay. How is Kubernetes different and why do we care? So for Python users, if you've ever tried to run like a PySpark job or streaming Python with MapReduce, you've probably run into the situation where you want a library and you can't install it. So you go to the systems administrator in charge of your cluster and they tell you no. Or alternatively, they install it and someone comes back and you broke their job. And so now someone's going to be unhappy and that's not great. The cool thing is it's got a lot more isolation. And so we can very easily ship competing, Python packages around. It might have better security with this increased level of isolation. In practice, though, like I don't actually think it's any better security. From following all of the Kubernetes security people on Twitter, it seems like they're doing just fine at breaking out of the containers, just as they were back when we had Yarn containers. So don't worry, everything's still broken. On the downside, it has a lot higher overhead. This increased isolation means that we have to use a lot more memory and a lot more system resources. And it's really difficult to cheat. And we're going to get back to that because it turns out that a lot of what big data tools have been doing in Yarn is cheating because it's really easy, right? Another important part is there's different scheduling primitives. So how we think about jobs and how we express them. Kubernetes came out of the very different use case where you would maybe be like scheduling a web app and you have a very different kind of schedule for a web app, right? That's going to be running forever compared to say a Spark executor, which might be running for like a little while. And we don't really do rolling updates to Spark executors, but we might want to do that to a web app and like other things like that. Another one is that storage was sort of an afterthought. And also, depending on which vendor you have, everyone has a slightly different idea of what the storage should look like. On the plus side, first-class network storage doesn't mean that it's actually supported by your vendor, but at the very least, the APIs are there. And in the Yarn world, that's really not the case. Another one is very different sort of ideas of exposing UIs. And this is very much a thing which like shouldn't really matter, but it turns out that the Spark developers were lazy, the Hive developers were lazy, and pretty much everyone you can think of is lazy. And so we have to rewrite a bunch of code because we made a lot of assumptions about how UIs work. And the last one is no built-in queues. And so this comes down to the resource sharing and how we might want to do it. And there's sort of two different approaches to solving this on Kubernetes. So why are we doing this? Like, why bother with Kubernetes? So the most important one is it has lots of industry adoption besides just the big data workspaces, right? And we have this magical promised land that we can use our spare production capacity for analytics workloads, right? And that sounds great. That sounds like I can run for free. Everything will be great. My resource manager will take all of my problems, et cetera, et cetera. Realistically, it's a great way to keep your resume up to date because there are a lot more Kubernetes jobs than there are Yarn jobs. So keep that in mind. So let's say we've agreed. We want to keep our resume up to date. Never know when it's time to find a new job. So we want to run on Kubernetes. How are we going to do that? So the first option is we can treat it like standalone mode. And that's where we just pretend that each container that gets scheduled by Kubernetes is almost a distinct computer. The easiest way to do this is there's a bunch of different operators that people have made, and they'll launch our jobs for us, and they'll just make it sort of look and feel like we have a lot of different computers. The downside is because our application isn't actually talking to Kubernetes directly, it's these other like operators that are doing that for us and scheduling for us. We don't have the same ability to dynamically scale. And it turns out that dynamic scaling is important. Option 2 is getting people like me to be less lazy. And if you find a good way to do this, let me know. And the downside of this one is that it involves a whole bunch of people like me repeating the same logic for each application. And this is because a lot of times we've made assumptions where we were like, yeah, we're going to do this because this is how it works in Yarn. And now we're coming to try and support Kubernetes. And we're like, okay, well, how do I make this Yarn feature work on Kubernetes? And then like 3 different people implement that same feature 4 different ways because, you know, one person had a little bit to drink. Coffee only, of course, don't worry. They just got excited and wrote 2 different implementations. And so it's maybe not ideal. And option 3 is that we look at this problem and we decide that our solution is another API on top of the existing APIs, because we can fix every problem with another layer of indirection. And that's sort of the unicorn and volcano approach there. So all kinds of fun. And personally, option 1 does not result in me having a job. Option 2 totally results in me having a job. And option 3 results in me having a very fun job. So I choose option 3. So we're gonna go ahead with that. So if we're going ahead with option 3, we get to sort of think about what are the scheduling primitives that we might want to use. And we're going to get to pretend that we can modify them a little bit because we're going to write new APIs on top of the sort of base APIs. And so in this situation, there's this API in Kubernetes called job, which is in theory designed for what Spark and Hive and all of those sort of things do. But it has some really weird restrictions that don't match the reality of the big data ecosystem. Namely, the biggest one is that if one part of my job succeeds, it will not scale up the job anymore. And it turns out that there are many reasons why one part of my job might succeed. Like I might be scaling down temporarily because, you know, I'm sitting here while the user is going out and having a cup of coffee, and then they're kind of come back to their notebook. And I do want to scale up after that. And so it's not great for that. It also has some restrictions around storage. And so personally, I think the one that most closely matches what we want to do tends to be stateful set because it gives us a lot of flexibility to scale up and down. It does have some downsides with forcing restarts on failures, but we can work around that. In practice, most people use pods because it's unfortunate. It requires the scheduler to keep track of each container and make requests individually. But it's sort of the simplest API, and so that tends to be where people get started. And so yeah, this is what happens in practice. This is my dog out at the beach. It turns out in practice, he tends to go for the closest dead fish. And we can think of the pod API as the closest dead fish that he wants to roll in. It works, but I have to hose him off afterwards. And similarly, yeah, we can make it work with the raw pod API, but there's so much more that we can do besides rolling around in dead fish.
Hey, Holden,
I'll
you got
admit
3
the
minutes
metaphor
left.
is a bit stretched. What?
Just quick time check. You got 3 minutes.
Awesome. Okay, storage, all kinds of fun, very broken. No need to worry. But really the point here is that similarly to with Yarn, we started out with sort of this idea that everything would be disaggregated. Then we realized, hey, that wasn't great. And then we added like things like PVCs and stuff like that. And people like having data persist. And so we sort of repeated a lot of the same learnings with storage that we had in Yarn. Quota enforcement, also super painful. Similarly to early Yarn, when we've got failures, it's really hard to figure out what's going on. Another one is dynamic allocation, super painful on Kubernetes. And this is because it won't let us cheat. And how dynamic allocation worked on Yarn is it let us cheat. When our jobs failed, we just had already written the data out to disk, and we would have a stay resident program on each node, just serve those files once our job was either failed or killed. And it turns out that like that's kind of what might be described as a security hole of letting anyone read anyone else's data. And so, you know, they didn't want that. But the good news is I drank a lot of coffee and talked with a lot of people, and we all agreed on coming up with a very sane plan that will definitely keep me employed for a while. If you're curious, you can look up this JIRA and you can see how we solved it. All kinds of future work. If anyone likes working on data infrastructure, please come and join me working on one of these things. If you like writing documentation, please come and join me. Please. And if you have questions, now is a great time for questions, if we've got any time left.
Yep, we've got some time for some questions. Any questions? I'm watching the chat here, so if you've got a question, please type it into the chat.
No one has questions. I can also just go and get more
Looks
coffee.
like there are no questions, and that is the sound of the
Okay,
kitchen timer.
awesome. Thanks for
Holden,
having me.
Thank you so much. Everybody give Holden a round of real or virtual applause, please. That was great. And next up is Steve.
Hey everybody, how are you doing? Sorry, you would think after almost a year of this, we'd all be better at the technical collaboration software, but I still constantly have to unmute myself when I think everyone can hear me. Yeah, thanks for everybody for coming this evening. I know that it's a lot to carve out of your evening, especially get to spend time with our families. So it's always encouraging to me when people still want to talk tech even after shop closes up. So thanks everybody for having me. Thanks Doug for running this. Shout out to a couple people I saw. Jeff Wallace. Jeff's a great guy. I saw he had a couple roles. He's a great guy to work for. So certainly keep him in mind. So what I wanted to talk to you about this evening is, as you can see on the title slide here, machine learning with real-time event streaming within Apache Kafka specifically. So I work for Confluent, which is the primary provider of Apache Kafka, which most people probably know, but for those that don't, it was a solution that was developed at LinkedIn back in 2009 or 10. And ultimately, Confluent was formed in 2014, originally just to provide support around Apache Kafka, and then ultimately to build this entire ecosystem. So that's who I work for. That is my day job. One of the things I always like to start with is something you can sink your teeth into. So you know what the end game looks like from a high level in a talk like this, because often it's like, you start with a slide and it's like, where's this guy going? So I like to just show you right off the bat what we're going to talk about, what the flow looks like in terms of machine learning within Apache Kafka and where it fits. And there are always alternative ways of doing this, but certainly we feel like compelling solution is Kafka in this space, and certainly the ability to do real-time streaming. As you can see, the components are the Kafka brokers, which take in events from various systems that contain features we believe may be valuable in the accuracy and ultimate consumability of our model. And we'll talk about what that is as well. Those events can be sent to whatever framework it is you use for machine learning. In our case, we show TensorFlow, but it could be Keras or anything else you want to use. The interesting part, and really the focus of what I want to talk about this evening, is the Kafka streams piece. So at a high level, we can deploy our TensorFlow model as part of a Kafka Streams application and ultimately perform prediction or inference, as the need may be, directly in Kafka Streams as new events are published to Kafka. So the example that I'd like to take to talk about, just from a high level, and this is actually something I worked on with a systems integrator in Michigan that specializes in this kind of work, is human activity recognition, or HAR for short. So what is it? And it's probably easiest just to give an example. Let's say you have a factory process that involves a mixture of human-based processes and machine processes. And we want to understand the end-to-end process so we can quantify performance, identify any problems, make improvements, all that kind of good stuff. First step normally you might think of is connecting your equipment to an IoT system and building out some insight tools that kind of tell you what's going on the floor right now. What's nice about that is sensors can emit events that we can capture and make actionable. In some cases, you might actually send them to a machine learning model, and others you might simply gather them for subsequent analysis. But a lot of processes actually involve humans, which historically are the blind spots. These are often the hidden causes of both problems as well as opportunities. And that's really where human activity recognition comes in. So human activity recognition is a branch of computer science. Largely, you can think of it as focused on just understanding human behavior. So it allows us to build sensors into our processes to understand what humans are doing. So rather than just, the devices that we might have on the plant floor that are actually hooked to machines, in this case, we're actually looking to do something that can observe what a human's doing. It goes back to the 1980s, and historically, it's a very hard problem to solve. But over the last few years, sensors are getting cheaper, better, all this kind of thing. And it's just really becoming more accessible. So it's a huge topic, but a few common examples are things like occupancy and location tracking, as well as gesture detection and tracking. And common use cases we see are like, if you think about it during COVID, the ability to track interactions between people, maybe just the proximity of people in a workspace. This can be invaluable for content tracing. Another example, and this is literally teaching, is like fall detection or prevention. So a machine learning algorithm can be used to detect if a person's fallen, for example, out of a hospital bed, or probably even more useful if they're about to fall. Many other applications are things like just general factory safety, is someone's hand stuck in a machine or something like that. And then of course there's more common examples we may see that are like retail applications. So by tracking where people spend their time in a store, we can optimize the layout of a store in terms of where we place things, those kinds of things. So for our example, we'll talk about interacting with a keyboard. And let's say the type of gestures rather that we're interested in following are typing and cleaning. But to do that effectively, we also have to understand when the keyboard's idle. And we also need to understand it's just someone walking by. We need to be able to differentiate between these common actions we take every day. And use cases would be things like tracking cleaning compliance in real time, or dispatching cleaning crews in real time, or just adjusting the schedule to be able to determine, does something need to be cleaned? Again, simple example, but hopefully it resonates. Balanced keyboard, inventory across workstations, that kind of thing. So the challenge is you have different types of keyboards and different types of people type, and the fact that keyboards are cleaned differently. We just, operationally, it's different to do this. Different people using them, different ways of cleaning, all these kinds of things. So the question becomes, how can we write software that handles all these variations? So traditional programming, my guess is the vast majority of people on this call have done at some point. You'll take input and you'll write a program for it. You'll take 2 times 2 and you'll write a program that says, let C equals A times B, and it will print out 4 when you pass in 2 and 2. Really good for simple, repeatable problems. As problems become more complex, that's when machine learning that you normally think of becomes more useful. So in this case, in the simple case, we provide the input and the desired result, and the computer iterates over different means of solving that problem and ultimately generates the program, or as we mentioned before, what we normally call a model. So the TensorFlow piece on that first slide would be the model in this case. So machine learning really allows computers to find hidden insights without being explicitly programmed where to look. That's probably one of the best definitions I've ever seen, without being explicitly programmed. Because again, we normally think, I've been doing this a long time, we think in terms of linear programs, where you have your main method and you just kind of go through and you have your for loops, and then ultimately you return a value. Machine learning is really designed to do that for you. So you have all these different means of performing machine learning with all these different algorithms. Ultimately, for what we're talking about, it would be something like a neural network. And again, you have a variety of these as well, like convolutional neural networks, recurrent neural networks, autoencoders, all different kinds of these that you can do. And largely those are the kind of algorithms that you'll find for something like this, in which you are looking to analyze video, images, anything like that, to be able to determine what someone's actually doing on a keyboard. So in this case, you would record different people interacting with the keyboards in different ways, and then you would ultimately label those interactions. You would say, if someone was typing, were they cleaning, or whatever, to be able to give the model the ability to determine what's true or false, for lack of a better word. And then ultimately you would train the model based on those interactions that are recorded. So ultimately what we do is we collect raw sensor data, we send the data to the model, and then we just use the model output. That all sounds really good and really easy. The problem comes when we look to deploy these models. Historically, that's been a large challenge. I mean, how do you operationalize this and keep them fresh? New keyboard types, new types of gestures. Real-time model training is we found one of the most effective uses of Apache Kafka. Time to value, as it relates to the data, is a key competitive advantage for organizations. You know, whether it doesn't really matter what you're doing, it's manufacturing, healthcare, financial services, retail, utilities. You know, almost anything you're doing at this point, data is a key competitive advantage. We've all heard the data is the new oil statement. That's what we're looking to provide is this ability to reduce your time to value as it relates to your data initiatives. And in terms of doing that with the data, the deployment has historically been, again, one of the largest challenges. Google published a paper several years ago that was titled Hidden Technical Debt in Machine Learning Systems. And as you can see here, only a small fraction of real-world ML systems is composed of the ML code as shown by the small black box in the middle. The required surrounding infrastructure is vast and complex. So it's kind of interesting because we generally think, you know, I want to be a data scientist. I want to write all these cool machine learning models and artificial intelligence and all these things. And it's really a lot of the plumbing work that goes around that just to make it usable in an enterprise is where the real challenge lies. So again, I'll go back to the first slide that we showed. And this is where this starts to come in. How do I make this actionable? So just to take a little bit of a brief sidestep here. So what makes Kafka different, and this becomes very relevant as it relates to machine learning. Kafka at its heart is just a distributed commit log. If you've ever seen an Apache web access log and you just type tail -f, you know, web access.log, chances are you would see some lines coming by that would have an IP address, a timestamp, the URL that was requested, the HTTP response code, the size in bytes, maybe some cookies, a lot of different things that are in that log. Kafka is similar to that conceptually, but it's distributed and durable across multiple servers. So for machine learning, this can be absolutely revolutionary. And the reason is for that is because you can now replay your training data. So as we develop our models and they require tweaking as we develop them, we can train our model over multiple permutations. And as we test and we look at our loss function and our feature engineering and all of these different things, we have to replay in order to generate that model. The same data can be provided to multiple frameworks and consumers, and you can also enrich it. So this is the beautiful part of Kafka is you have this ability to have this replayable log. Again, just think of an Apache web access log. If you were going to process it, and I used to have to do this very, very painfully with Python, you can, you know, just sit there and read the log again and again and again. You'd never go back and change any of it. It's immutable. So for loading and training machine learning models, it's a real game changer. So what would this look like in operation? So we might have something like this. We might have data stores with operational data, some applications, maybe some IoT. In this case, at the end of the day, the way that we did this with this human activity recognition model I was describing, that was ultimately cameras that were taking pictures of keyboards, just small little hardware devices that were installed, and ultimately surface all of this data into Kafka here in the middle. And then ultimately you end up with this ability now to publish that training data over and over and over again to our machine learning model. And this is where it becomes really powerful because now we can take the model and we can extract. There are a variety of ways we'll talk about. You can do that. You can take that model and deploy it within a Kafka Streams application so that when new events come in, they can be scored, or you can do inference against them, a prediction, whatever it is you need to do. As events are occurring. And the beautiful thing about that as well is that you can actually enrich those. You can join those. So like in our cases, we'll see later, we may join keyboard events to locations or something like that, all in real time. So there are a couple different ways you can do this. You can do this where you have an input event that comes into Kafka Streams, and Kafka Streams then makes an RPC call, generally something like HTTP to TensorFlow that has this TensorFlow serving component. And you would send, you know, whatever it is your event is, the payload for your event to your model, TensorFlow serving would perform a scoring or prediction, whichever is relevant, and then send back the results. And then you would do something with that prediction within Kafka. That's one way to do that. The other way to do that is all within Kafka streams. And this is the really probably the more the focus of the conversation this evening, is this ability to input an event directly into Kafka streams, have the scoring and the prediction occur directly here, and then send it to multiple places downstream that might need that data. So what are the pros and cons? So the pros of a model server, which again, this is where you do the external call to something like a TensorFlow serving or an H2O, Amazon SageMaker, or Data Robot, one of these other ones, is that you have simple integration with existing technologies and organizational processes. So you can have a Kafka Streams app. As this event hits Kafka, that somebody clicks something, or they're on the keyboard, or someone's walking by, or whatever, and you can take that event and turn around and make an HTTP call out of Kafka Streams. That's nice because it just works. You don't have to do a lot. It's also easier to understand if you're coming from a non-streaming world. It just becomes this kind of API-driven approach, which most organizations are familiar with. Later migration to real streaming is also possible, which is the second model that we talked about. And I'm sorry, I think I jumped ahead. Or jumped back, one of the two. There we go. So the cons of doing it this way, or the pros of deployment in the streaming app, if you want to look at it that way, worse latency, right? Because we're calling outside of our application and we're making this HTTP call. Doesn't mean it's bad, it just means it's something, it is a con. It's something you would have to at least consider as the worst latency. No offline inference. In some cases, you might find that you deploy a Kafka Streams app at the edge, like in the store or something like that, and you don't want to call out to a data robot or some other kind of centralized place where you can do model serving. And then also you're coupling the availability, scalability, and the latency of your Kafka Streams app to like an external system. So you've kind of complicated your attack surface from the standpoint of performance, troubleshooting, or availability, or anything like that. And then side effects. One of the things in Kafka processing, especially in streams, is exactly once processing. And as soon as we call out for something, potentially we at a minimum, we complicate that as a solution. So again, back to, I'll keep showing you this slide just to keep us on track, that ultimately you have the data in the Kafka brokers, which is sent to the TensorFlow model. Again, it could be anything, PyTorch, it could be anything, and then ultimately deployed into Kafka Streams. So you can do this a couple of different ways. One is with something like Keras. And so Keras is a Python-based framework that allows us to use TensorFlow and a number of other libraries for both model building as well as generating an output model that can be imported into other programs, which is what we'll talk about. So this is a very simple subset of what that might look like within a Kafka Streams app. You can see where you would simply import your H5 file, which is kind of the canonical format in Keras, for a model against which we would do prediction. And then down here, you can see we pass in our inputs, and then here we ultimately get our score, and then we return it. And we can do all of this as it flows through Kafka. The other way is something like with just straight TensorFlow. So if you've written any TensorFlow code, you might be familiar with this save model bundle and loading it, creating a session in TensorFlow. And then ultimately creating with that session object, we ultimately will, again, get our prediction and be able to do whatever it is we need to do with that. So that's one way to do it, is in straight Java. Another way is with KSQL. So KSQL is just a SQL-based stream processor, so you can think of it. This is where I was talking about earlier. You might take in events, like a sensor input event from our keyboard. You might join it to location, and then ultimately use this for perhaps our training data. So that's another big thing. You can use enriched training data that you can replay over and over and over again, pulling it out of Kafka.
Hey, Steve, quick time check. You got 3 minutes.
All right, good deal. I think we're almost dead on. Ultimately, what's nice about it is you can actually create a persistent stream. So as these events come in, you might say, you know, from that stream I just created where I joined keyboards and locations, I want to get every single column from those two streams that have their own respective payloads as they're surfaced in Kafka. And then I've got my model inference function that I pass in my samples, and then I get out my status. The beautiful thing about that is that allows you to do this this kind of distributed processing for downstream systems. So in this case, we've got our camera, we've got our keyboards. Perhaps we're surfacing this through something like MQTT into Kafka. And then ultimately, our model that we have previously built that we have deployed within Kafka Streams or KSQL, either one, we consume the sample, we score it, and we publish it back to Kafka, where we can now distribute that to other downstream consumers. That's where it gets, if you take nothing away from this talk, remember that. If you can do the scoring, it's kind of a write once, read many model. So you can get the score and then distribute it to multiple systems in a format that's meaningful to them. So your data warehouse might need it in one format. Elastic, I mean, think of the possibility like in a retail app, if you could actually take the scoring that you had done on a recommendation model and join it to the categories and ultimate purchases of those consumers and then surface that to a dashboard where you could actually see, oh, wow, our recommendations are more effective this afternoon. What did we change? That kind of thing. And then a microservice to alert, in our case, it would have been, not in a retail application, but in our keyboard app, you might have a microservice that would alert custodial management. Hey, you need to clean building G or whatever, because it hasn't been cleaned in 3 hours. So a lot of different options you've got as it relates to that. So it's really exciting. It's worth looking at. I mean, machine learning is like anything else. You can probably do it 100 different ways, but we think this is really compelling because, like I said, you can replay the data. And ultimately, you can deploy the model. I didn't get a chance to talk about it. You can ping me offline if you're interested. But the way you deploy that model back into Java is with a really cool framework called DL4J. And that actually includes like the C-based linear algebra libraries. So you can actually use those from within Java. And it's, you don't suffer the performance impact sometimes you do with Java. So good stuff. That's what I have. Hopefully that's useful to you. Like I said, feel free to reach out to me if you want to just chat about it on the side or anything. I'm always open for a conversation on that.
Awesome. Thank you, Steve. We've got a few seconds here for one last question. Any questions? Any quick questions here? I do have one quick question here. And there was one slide that had, it looked like a skull at the bottom. Like what was that?
That is, so we've got a standard icon library, and for whatever reason, I'll be honest with you, I don't have a good answer. That's our icon for machine learning. I'm not sure why that's the one, but
like a robot head. Okay.
Oh, there you go. There you go. That's good. Hey, that's great.
Okay, I saw that and I was like, I didn't want to interrupt you, but I was like, what is that?
No, all good. Yeah, thanks, guys. Appreciate you taking the time.
Cool. Hey, thank you very much, Steve. Next up is Andre. And Andre, whenever you're ready, take it away.
Thanks, Doug. Can you guys hear me and see my screen?
Yes, I can. It's full screen right now.
Great. I'll make my presentation a little bit shorter. So just kind of to follow the first speaker, a little bit of background on myself. As you can hear from the accent, I was not born in the US, so originally from South Africa. Have a PhD in artificial intelligence from the University of Bristol in the UK. Was an academic for 23 years, worked at Advanced Analytics Software Company in North Carolina for 9 years, and now I've been at IBM a couple of years, part of the Data and AI Expert Labs, and I'm the academic technology lead. So tonight I'm going to present Open Data Science for All. It's an open education project with the aim of accelerating the development of data science curricula worldwide. So here in the US, we sometimes think we don't have a lot of resources, but we are actually spoiled, especially if you come to universities. There are many universities worldwide that really wants to get into data science, but don't have the resources. They don't have enough funding, skilled personnel, and curricula to start data science programs. So this project is aimed to help accelerate the development of data science curricula worldwide. And then also for established programs, there might be some content in here as well that you can use. So although this is an open education project, we run it as an open source software project on GitHub. And therefore we are part of the Linux Foundation Data and AI. And thanks to Doug and John Murtick from the Linux Foundation for giving me this opportunity to present tonight. If you'd like to contact me, that's my email address, andre.dewaal@ibm.com. Just be careful, it's 2 A's and 1 L, not 1 A and 2 L's most people get that wrong, and sometimes computer systems want to change that as well. So we have a really nice one-pager, and if you're interested, just contact me and I'll forward that to you. That kind of summarizes what this project is all about. I know it's a little bit small, so I broke it up into 3 pieces. So first of all, as I said, this is a project that basically creates building blocks for data science curriculum. And we based it on Python, as it seems to be becoming the predominant language in data science. Now, IBM didn't build this software repository itself. We actually had 2 professors from the University of Pennsylvania, Zach Ives and Susan Davidson from Computer and Information Science, and we got them to build the initial modules for us. Now, they have a program in big data, so that's the connection with the Cleveland Big Data Group. So this is based on an introductory course in data science, but from a big data perspective. So our partners is then also the Linux Foundation. They provide the infrastructure and ensure updates and growth. IBM sponsored the project, but it's completely IBM agnostic in the whole of the project. Nowhere will you find the term or the name IBM. It's also not dependent on our software. You can run the Jupyter notebooks on any platform that you wish. So the goal, accelerate the development of data science worldwide. So we try to cover the core of data science. We currently have 15 modules. Each module covers 50 minutes, and some of the modules like the neural networks, you might need 2 or 3 classes. We focused on Python, but we are open to contributions on R or translation of the Python notebooks to R, and most of the modules are independent, so you can mix and match. For instance, if you're interested in doing a weekend bootcamp on data science, you can select a number of these modules and put that together into a really nice bootcamp. It's available from everywhere at no cost. The licenses are the Creative Commons license and Apache 2.0, so permissive licenses basically use the content as you wish, build a company on it, whatever you want to do, as long as you acknowledge that you got it from this project. We have a really nice technical steering committee looking after the project, not kind of giving a lot of detail on each of these faculty members, but David Mongo from Berkeley Institute of Data Science, he's very well known. The 2 professors from UPenn that developed the content. Jennifer Priestley is very well known. She's from Kennesaw State University. She got the first PhDs in big data approved by the state of Georgia a couple of years ago. And I think she's busy with the 20th or so PhD in big data, delivering and supervising that. Then where the first program in advanced analytics was started at NC State, one of the faculty members, Professor Eric Labar, a marketing professor from Oklahoma State University, Gautam Chakraborty. And recently we added 2 new professors, one from University of Washington, Alok Demirkan, and then also Arya Chernik from Duke University to help us with community building around the project. That's my manager, Anna Isheveri, myself, I'm the chairperson of the technical steering committee, and then we have SAS Institute, James Arun, involved in the project as well. So really fantastic group of professors. If you like working with academia, please join us. And there are lots of interesting and novel things to do in this project.
Hey, Andre, could you go back to the prior slide? So on the middle one, the OSU,
yes.
That was not Ohio State, because there's only one OSU, and that's Ohio State. I just need to make sure you're aware of that.
Yeah, this is Oklahoma State University. I know, yes. Thanks for correcting me. Right, so we tried a kind of nice data sciencey way of representing what we have. So as I said, the 15 modules try to cover the core of data science. We have an introductory lecture, some stuff on how your computer works for non-computer science students. Then a really nice lecture on data wrangling, where we do some web scraping and testing of hypotheses, how to represent your data visualization, always important. Once you've built all your models, to pick the best one, and then in the world that we live in, ethics is very important. So ethics shouldn't really be a lecture at the end. It should be interweaved with all the other lectures. Then you have 4 modules or lectures on machine learning, covering neural networks, decision trees, random forests, linear and logistic regression, and then also under unsupervised machine learning, k-means clustering, and principal component analysis. Then, because this was developed at UPenn and they have a big specialization in big data, we have 4 modules that looks at graph processing, things like page rank, order of queries in SQL, and we also have a notebook on Apache Spark to show how distributed processing can be done. So if you're interested in contributing something around big data, we would really love to have you contribute something to the repository. So here's just a description of the lectures represented in a different way. So each lecture, 50 minutes at least, and has an accompanying Jupyter notebook. So we believe that to be a real data scientist, you should be able to program, and you can't just watch videos. As they say, you can watch many videos on riding a bicycle, but in the end, when you want to ride a bicycle, you actually should get on a bike and pedal. The same with data science, you should do some programming at the end. So the project we launched last year at the end of February, just when the world basically shut down. But now we're getting back to normal, and most university faculty has moved all the stuff online. So hopefully we'll be able to get some more contributions. We are currently working with 2 universities. Rochester Institute of Technology and Rensselaer Polytechnic Institute. They have actually courses on open source that they teach that students can work on for credits. So we have 2 students from Rochester, Rensselaer Polytechnic Institute that's going to create a module for us on deep learning, and the other one on natural language processing. So a lot of time people ask, okay, if I contribute something, do I get a reward? Yes, you can get a reward for contributing something to this project. So we have 2 Credly badges managed by the Linux Foundation. So you can get a technical steering committee badge or a contributor badge, and maybe the easiest one at this stage is to go for the contributor badge. And there are lots of things you can do. Recently, we started translating the content into German. There are 2 separate tracks where we are busy translating the content of the repository into Portuguese and Spanish as well, with a couple of MOOCs being built. You can translate some of the Python code to R, contribute new content on distributed processing, big data, machine learning, record, make a video of one of the modules, talk or have a, workshop or bootcamp at a conference. So there are many ways to contribute to the project. So if you're interested, contact me. I'll go back to the first slide where my email address is andre.dewaal@ibm.com. So we would love to have you guys work with us. If you know of a university that you think this might be useful, please contact me, and I can then reach out to the university and see if we can support them. So thanks very much, Doug.
Awesome. Thank you, Andre. That looks really, really great. We've got a few minutes left. Does anybody have any questions? Oh, okay, here's a question from Vipin. How different is OpenDS for All from AI for All?
I cannot really say how different it is from AI for All, but I can maybe discuss how different is it different from what Berkeley is doing with their Data 8. So Data 8, basically the assumption is they're looking from a computational modeling, I think, viewpoint and statistical inference. So this is more from a big data viewpoint. It's also at a pretty comprehensive level. So this was developed for a master's class, although it was an introductory level. So this is at a 500 level, so a master's level at UPenn. So the content is really, really fantastic. And we did a couple of boot camps already at Imperial College London and University of Liverpool. And these are some of the top universities in the world, and they really enjoyed and appreciated the content and the quality of the content. So this is a real university course developed by professors, and that can be used to accelerate the development of data science. Hope that helped.
Thank you. Again, thank you coming in from Vipin. Looks like it answered the question. So one question I've got is the age-old Python and R. I mean, I know you commented earlier that Python seems to be the dominant data science language. I did see in a previous slide or two that one of the other efforts was converting some of the existing Python to R.
Yes.
Is that to bring the R programmers along into like what? It seems like it's going in both directions.
Yes,
Does that make
exactly.
sense? Like the Python's expanding, but then you're also backporting, or I shouldn't say backporting. That's but you're also porting Python to R.
Exactly. So the code will probably might have to take a different approach for some of the Python programs, but especially in different parts of the world, like Europe, R has got a big following. Some of universities are named. Here in the US, Python is very strong, but we don't really have a preference. We just didn't have the resources at the beginning to have all the notebooks in R and Python. So we're actively soliciting rewriting or new notebooks in R as well.
Cool, thank you. Any other questions for Andre? Going once, going twice. Let's give Andre a big round of applause. Andre, thank you so much.
My pleasure.
That's great stuff. This is the this is the end of the meetup. And again, I'd like to thank everybody, Holden, Steve, and Andre for speaking. And again, if you've got an interest in participating in that CS education, you've got the contact information from earlier in the meetup. Look out for us for the September meetup. I'm hoping to at least have a small hybrid event for at least the folks that feel comfortable meeting in person. And yeah, again, thanks for coming, and stay safe, everybody. Have a good night. Thank you.